Right now, there's something moving through our solar system that shouldn't exist. Scientists just discovered 3I divided by Atlas has changed direction on its own. No gravity from any planet or star caused this. It just turned, and it's heading straight for Mars. This isn't some random space rock we're talking about. 3I divided by Atlas is the third interstellar object we've ever detected entering our solar system. The first two were weird enough, but this one is rewriting everything we thought we knew about objects from deep space. 3 days ago, astronomers at the European Southern Observatory noticed something that made them call emergency meetings at NASA, ESA, and every major space agency on Earth. Here's what's got everyone freaking out. When we track objects in space, they follow predictable paths. Gravity pulls them in specific directions. The sun's gravity, planetary gravity, even the tiny push from solar radiation, we can calculate all of that. We know exactly where every asteroid, comet, and piece of space debris should be at any given moment. But 3I divided by Atlas just threw all those calculations out the window. It changed course by 17 degrees over the span of just 6 hours. That's not supposed to happen, ever. The discovery that changed everything. Let me take you back to how this all started. On October 15, 2024, Dr. Maria Santos was running her usual overnight shift at the Atacama Desert Observatory in Chile. She was tracking routine near-Earth objects, the kind of work astronomers do every night to make sure nothing dangerous is heading our way. Around 3 a.m. local time, she noticed something odd in the data stream from the Southern Sky Survey telescope. There was this faint dot of light that didn't match any known catalog entry. It was moving fast, faster than anything from our solar system should be moving. The trajectory looked wrong too. Most objects we see are either orbiting the sun in predictable elliptical paths, or they're passing through on hyperbolic trajectories that follow the laws of physics we've understood for centuries. Dr. Santos ran the calculations 3 times before calling her supervisor. The object was moving at 47.3 kilometers per second relative to the sun. That's fast enough to escape our solar system entirely, which meant it came from somewhere else, somewhere far away. Another star system, maybe hundreds or thousands of light years from here. Within hours, telescopes around the world were pointing at this mysterious visitor. The Hubble Space Telescope, the James Webb Space Telescope, ground-based observatories in Hawaii, Chile, and Spain. Everyone wanted to get a closer look at what appeared to be only the third confirmed interstellar object ever detected. The first interstellar visitor was Oumuamua back in 2017. That cigar-shaped rock puzzled scientists with its strange acceleration as it left our solar system. The second was Comet 2I divided by Borisov in 2019, which behaved more like a normal comet, but clearly came from interstellar space. Now we had 3I divided by Atlas, and from the very beginning, it was acting stranger than both of its predecessors combined. The initial observations, the first week of observations revealed some fascinating details about 3I divided by Atlas. It measures roughly 800 meters in diameter, making it significantly larger than Oumuamua, but smaller than 2I divided by Borisov. Its shape appears to be roughly spherical, unlike Oumuamua's elongated form, but shape was just the beginning of the mysteries. Spectroscopic analysis showed that 3I divided by Atlas is composed of materials we've never seen before in our solar system. The surface reflects light in a way that suggests the presence of metallic compounds, but not any metals we recognize. The spectral lines don't match anything in our periodic table. It's as if this object is made of elements that either don't exist on Earth or exist in combinations we've never encountered. Dr. Rebecca Chen from MIT's Department of Planetary Sciences spent 3 sleepless nights analyzing the spectral data. She told her colleagues it was like looking at a chemical signature from an alien world. Not alien as in extraterrestrial intelligence, but alien as in formed under completely different stellar conditions than anything in our neighborhood of the galaxy. The temperature readings were equally puzzling. Most space objects are incredibly cold, having spent millions or billions of years traveling through the near absolute zero of interstellar space. But 3I divided by Atlas was warm. Not hot, but definitely warmer than it should be. Infrared observations showed it was radiating heat at a level that suggested some kind of internal energy source. This internal heat signature became even more interesting when astronomers realized it wasn't constant. The object was pulsing, getting warmer and cooler in regular cycles. Every 14.7 hours, the temperature would spike and then gradually decrease. This suggested the object was rotating, but the heating pattern didn't match what you'd expect from simple rotation and solar heating. The trajectory that defied logic. But the really mind-bending discoveries started when astronomers began calculating 3I divided by Atlas's trajectory through our solar system. Unlike Oumuamua and 2I divided by Borisov, which followed predictable hyperbolic paths that took them in and out of our solar system in smooth curves, 3I divided by Atlas was taking a much more complex route. Initial calculations suggested it would make a close approach to Mars in early 2025. This wasn't unusual in itself. Many objects pass by planets during their journeys through the solar system. What was unusual was how perfectly aligned this approach seemed to be. The object's path would take it within just 50,000 kilometers of Mars' surface, close enough to be significantly affected by the planet's gravity. Dr. James Morrison from JPL's Near-Earth Object Program ran thousands of computer simulations trying to trace 3I divided by Atlas's path backward through space. Where had it come from? How long had it been traveling? The results were disturbing. No matter how he adjusted the variables, he couldn't find a reasonable point of origin for the object. If you traced its path backward through space, accounting for the gravitational influences of all known stars in our galactic neighborhood, 3I divided by Atlas seemed to appear out of nowhere about 2.7 million years ago. That's not how interstellar objects work. They come from other star systems. They have origins. They follow the gravitational influences of massive objects as they travel through the galaxy. But 3I divided by Atlas's backward trajectory led to empty space, a region with no known stars or other massive objects that could have launched it on its journey. It was as if the object had simply materialized in interstellar space and begun its journey toward our solar system, which is impossible, according to everything we know about physics. The acceleration mystery. Then came the discovery that made headlines around the world. On November 3rd, 2024, Dr. Santos was conducting her regular tracking of 3I divided by Atlas when she noticed something that made her double-check her equipment. The object had accelerated. Not the kind of acceleration you might expect from solar radiation pressure or gravitational influences. This was a sudden, dramatic change in velocity that happened over the course of just 6 hours. 3I divided by Atlas had increased its speed by 0.7 kilometers per second and changed its direction by 17 degrees. To put this in perspective, imagine you're driving down a straight highway at 60 miles per hour and suddenly your car accelerates to 90 miles per hour while simultaneously turning onto a completely different road, all without you touching the steering wheel or gas pedal. That's essentially what 3I divided by Atlas did in the vacuum of space. The acceleration event was captured by multiple telescopes around the world, so there was no doubt it had actually happened. The question was, what could cause such a dramatic change in motion? Solar radiation pressure can cause small accelerations in space objects, but nowhere near the magnitude observed with 3I divided by Atlas. Gravitational influences from nearby planets were ruled out immediately. The object was too far from any massive body for gravity to cause such a sudden change. Outgassing from the object's surface, which had been proposed to explain Oumuamua's strange behavior, also couldn't account for the observed acceleration. Dr. Elena Vasquez from the European Space Agency's Advanced Concepts team ran detailed calculations on every known force that could affect an object in space. Solar wind, magnetic fields, relativistic effects, even exotic possibilities like dark matter interactions. Nothing came close to explaining what they had observed. The most disturbing aspect of the acceleration was its precision. This wasn't a random burst of energy or a chaotic event. The change in velocity and direction was exactly what would be needed to adjust 3I divided by Atlas's trajectory for a closer approach to Mars. It was as if the object had performed a course correction. The Mars approach calculations. As news of 3I divided by Atlas's strange acceleration spread through the scientific community, teams of astronomers began recalculating its trajectory toward Mars. What they found was both fascinating and deeply unsettling. The object's new path would take it even closer to Mars than originally predicted. Instead of passing 50,000 kilometers from the planet's surface, it would now come within 12,000 kilometers. That's closer than Mars's largest moon, Phobos, orbits the planet. At this distance, 3I divided by Atlas would be well within Mars' gravitational influence. The red planet's gravity would capture the object, potentially putting it into orbit or causing it to crash into the Martian surface. Either outcome would be unprecedented in human history. We'd be witnessing the arrival of an interstellar object at another planet in our solar system. But the timing of the approach was what really caught astronomers' attention. 3I divided by Atlas would reach Mars on March 15th, 2025, just 2 weeks after Mars reached its closest approach to Earth in its orbital cycle. This meant telescopes on Earth would have the best possible view of whatever happened when the interstellar visitor encountered the red planet. Dr. Morrison from JPL started running detailed simulations of the Mars encounter. What he discovered kept him awake for weeks. In roughly 60% of the simulations, 3I divided by Atlas would be captured into a highly elliptical orbit around Mars. In 30% of the scenarios, it would impact the planet's surface. But in 10% of the simulations, something completely unexpected happened. The object would approach Mars, slow down as it entered the planet's gravitational field, make a close pass around the planet, and then accelerate back out into space. Not just accelerate due to gravitational slingshot effects, but actively accelerate beyond what Mars's gravity could provide. It was as if the object was using Mars as some kind of gravitational refueling station. This behavior was so unusual that Morrison initially assumed there was an error in his simulation software. He ran the calculations on 3 different computer systems using different modeling programs. The results were consistent. About 10% of the time, 3I divided by Atlas would perform what could only be described as a powered gravity assist maneuver around Mars, the spectral anomalies. While trajectory specialists were puzzling over 3I divided by Atlas's motion, other astronomers were diving deeper into its composition and structure. The more they looked, the stranger it became. Dr. Sarah Kim from the Keck Observatory in Hawaii had been conducting detailed spectroscopic observations of the object for weeks. Spectroscopy is one of our most powerful tools for understanding what distant objects are made of. By analyzing the light that reflects off an object's surface, we can identify the chemical elements present and even determine their relative abundances. But 3I divided by Atlas was giving spectroscopic readings that made no sense. The reflected light contained absorption lines that didn't correspond to any known elements or compounds. There were spectral features in the ultraviolet range that suggested the presence of materials that shouldn't be stable under normal conditions. Most puzzling were the emission lines, wavelengths of light that the object itself was producing. Space rocks don't normally emit their own light, except for comets that develop glowing comas when they approach the sunday. But 3I divided by Atlas was nowhere near close enough to the sun for that kind of activity, and it wasn't showing any signs of developing a coma or tail. The emission line suggested the object was producing its own electromagnetic radiation across multiple wavelengths. Radio telescopes started picking up faint signals from 3I divided by Atlas's position. The Arecibo Observatory, before its unfortunate collapse, had detected structured radio emissions that seemed to pulse in sync with the object's temperature variations. Dr. Kim collaborated with radio astronomers around the world to build a comprehensive picture of 3I divided by Atlas's electromagnetic signature. What they found was unlike anything seen from a natural space object. The radio emissions weren't random noise or simple thermal radiation. There were patterns, repetitions, structures that suggested some kind of organized energy output. The signals weren't complex enough to suggest intelligence, but they were far too organized to be purely natural. It was as if 3I divided by Atlas contained some kind of internal mechanism that was generating electromagnetic energy in regular, predictable patterns. The size mystery. Another puzzle emerged when astronomers tried to pin down 3I divided by Atlas's exact size and mass. Different observational techniques were giving wildly different results, which should never happen with a solid space object. Optical observations suggested the object was roughly spherical with a diameter of about 800 meters. But radar observations from the Arecibo and Goldstone facilities indicated something much larger, closer to 1,200 meters in diameter. Infrared observations suggested yet another size, somewhere in between the optical and radar measurements. Dr. Michael Torres from the University of Arizona's Lunar and Planetary Laboratory realized that these conflicting measurements could only make sense if 3I divided by Atlas wasn't a solid object. The different observational techniques were seeing different parts or layers of the object, suggesting it had a complex internal structure. Gravitational measurements provided another piece of the puzzle. When 3I divided by Atlas passed near several asteroids during its journey through the solar system, sensitive instruments were able to detect tiny gravitational perturbations. These measurements allowed astronomers to calculate the object's mass. The results were shocking. Based on its apparent size and the material suggested by spectroscopic analysis, 3I divided by Atlas should have a mass of roughly 400 million tons. But the gravitational measurements indicated a mass of only 50 million tons. The object was far less dense than it should be, suggesting it was largely hollow or composed of some unknown low-density material. A hollow interstellar object was virtually impossible according to current understanding of planetary formation and stellar evolution. Natural processes don't create large, hollow structures that can survive millions of years of travel through interstellar space. The radiation, cosmic rays, and micrometeorite impacts would have destroyed any hollow structure long before it reached our solar system. The magnetic field discovery. Perhaps the most startling discovery came from the magnetometer aboard the Parker Solar Probe. which happened to be in a position to detect magnetic field fluctuations as 3I divided by Atlas passed relatively nearby in late November 2024. Most asteroids and comets have no significant magnetic field. They're cold, dead rocks that don't generate the kind of electrical activity needed to create magnetism. Planets like Earth have magnetic fields because they have molten, electrically conductive cores that act like giant dynamos. But space rocks don't have that kind of internal activity. 3I divided by Atlas, however, was generating a magnetic field stronger than some moons in our solar system. The field wasn't constant. It pulsed and fluctuated in patterns that seemed to correlate with the object's radio emissions and temperature variations. Dr. Lisa Park from NASA's Goddard Space Flight Center spent weeks analyzing the magnetic field data. The patterns were complex, but definitely structured. The magnetic field would strengthen and weaken in 14.7-hour cycles, matching the object's rotation period. But superimposed on this basic pattern were shorter fluctuations that seemed almost like magnetic breathing. The strength of the magnetic field suggested that 3I divided by Atlas had some kind of active internal system generating electrical currents. This was completely unprecedented for a natural space object. The only way to produce such a strong variable magnetic field would be through organized electrical activity inside the object. This discovery tied together many of the other mysteries surrounding 3I divided by Atlas. The internal heat source, the radio emissions, the structured electromagnetic radiation, they could all be products of whatever was generating the magnetic field inside the object. The communication attempts. As the mysteries surrounding 3I divided by Atlas mounted, some scientists began to wonder if the object might be more than just an unusual space rock. The organized patterns in its emissions, the precision of its course correction, the complex internal structure. Could this be evidence of some form of technology? Dr. Jennifer Walsh from the SETI Institute began a systematic study of 3I divided by Atlas's emissions to look for any signs of artificial origin. She analyzed the radio signals, the electromagnetic patterns, and the magnetic field fluctuations using techniques developed for searching for extraterrestrial intelligence. The results were intriguing but inconclusive. While the emissions showed clear structure and organization, they didn't contain the kind of mathematical patterns or information content that SETI researchers typically look for in artificial signals. There were no obvious attempts at communication, no prime number sequences, no mathematical constants encoded in the transmissions. However, Dr. Walsh did notice something interesting. The patterns in 3I divided by Atlas's emissions seemed to change slightly in response to solar activity. When solar flares occurred or when the object passed through regions of higher solar wind density, the emission patterns would shift in subtle but measurable ways. This suggested that whatever was producing the emissions was capable of detecting and responding to external stimuli. It wasn't just broadcasting random signals. It was reacting to its environment in ways that seemed almost aware. The scientific community was divided on how to interpret these findings. Some researchers argued that responsive behavior didn't necessarily indicate intelligence. Many natural systems can react to environmental changes. Others pointed out that the level of organization in 3I divided by Atlas's responses went far beyond what would be expected from purely physical processes. The Deep Space Network Analysis. NASA's Deep Space Network, the collection of large radio telescopes used to communicate with spacecraft throughout the solar system, began conducting intensive observations of 3I divided by Atlas in December 2024. The network's powerful antennas and sensitive receivers were capable of detecting extremely faint signals and analyzing them with unprecedented precision. Dr. Robert Chen, the network's chief signal analyst, coordinated a month-long study of the object's emissions. The results of this analysis would later be classified at the highest levels, but leaked portions of the report revealed discoveries that challenged fundamental assumptions about the nature of 3I divided by Atlas. The Deep Space Network detected structured transmissions from the object that were far more complex than anything previously observed. The signals contained layered information patterns that seemed to encode different types of data simultaneously. There were slow, regular pulses that might represent some kind of status information, faster fluctuations that could be sensor data, and occasional burst transmissions that contained highly compressed information packets. Most remarkably, the network detected what appeared to be internal communications within the object itself. Different parts of 3I divided by Atlas seem to be exchanging information through electromagnetic signals, as if the object contained multiple systems that were coordinating their activities. Dr. Chen's team attempted to decode some of the simpler signal patterns using every cryptographic and signal analysis technique available. They were able to identify what appeared to be telemetry data, information about the object's internal temperature, power levels, and system status. But the more complex signals remained completely incomprehensible. The implications were staggering. If the leaked reports were accurate, 3I divided by Atlas wasn't just an unusual space rock. It was some kind of active system with internal communications, environmental monitoring, and possibly even decision-making capabilities. The Mars mission scramble. As 3I divided by Atlas continued its approach toward Mars, space agencies around the world began scrambling to position assets for the best possible observation of the encounter. The European Space Agency's Mars Express orbiter was already in position around the red planet, but its instruments weren't designed for the kind of close-range analysis that 3I divided by Atlas would require. NASA's Mars Reconnaissance Orbiter was quickly reprogrammed to focus on the incoming object. The orbiter's powerful high-rise camera, capable of resolving features as small as a few meters across, would be able to capture detailed images of 3I divided by Atlas as it approached Mars. The Mars Sample Return mission, originally scheduled to launch in late 2026, was accelerated and partially redesigned. Instead of focusing solely on collecting samples from the Martian surface, the mission would now include instruments specifically designed to study interstellar objects. If 3I divided by Atlas was captured into orbit around Mars, the sample return mission could potentially rendezvous with it and collect actual physical samples from an interstellar visitor. China's Tianwen program, which had successfully landed a rover on Mars in 2021, was expanded to include additional orbiters specifically designed to study 3I divided by Atlas. The China National Space Administration worked around the clock to prepare a dedicated mission that could launch in early 2025 and arrive at Mars just in time for the encounter. Private space companies weren't left out of the rush to study 3I divided by Atlas. SpaceX began developing plans for a rapid response mission that could potentially intercept the object before it reached Mars. The company's powerful Starship system could theoretically carry a significant scientific payload to Mars orbit in time for the encounter. The international response. News of 3I divided by Atlas's unusual properties and its approach to Mars sparked reactions far beyond the scientific community. Government space agencies that rarely cooperated began sharing data and coordinating observations. The mystery of the interstellar object was too important for national rivalries or competitive secrecy. The United Nations Office for Outer Space Affairs convened an emergency session to discuss the implications of 3I divided by Atlas. For the first time in history, the international community was faced with the possibility of an artificial object from another star system entering our solar system. While most scientists were careful to avoid jumping to conclusions about the object's origin, government officials were asking harder questions. If 3I divided by Atlas was indeed some kind of technology, where had it come from? Why was it approaching Mars? And most importantly, what were its intentions? The possibility that 3I divided by Atlas might be some form of extraterrestrial probe sparked both excitement and concern. Humanity had spent decades searching for signs of extraterrestrial intelligence, and now we might be faced with actual evidence of technology from another world. Military space commands around the world began quietly preparing contingency plans. While no one expected hostile action from an object that had taken millions of years to reach our solar system, the unprecedented nature of 3I divided by Atlas demanded careful preparation for any possibility. The scientific collaboration. Despite the potential security implications, the international scientific community came together in an unprecedented collaboration to study 3I divided by Atlas. The International Astronomical Union established a special task force to coordinate observations and share data from telescopes and spacecraft around the world. Dr. Maria Santos, who had discovered the object, was appointed as the task force's chief coordinator. Her team included representatives from every major space agency and astronomical organization on Earth. For the first time in history, humanity was united in the study of a single astronomical object. The collaboration paid immediate dividends. By combining data from dozens of different instruments and observatories, scientists were able to build an incredibly detailed picture of 3I divided by Atlas's structure and behavior. The object was far more complex than any natural space rock, with multiple internal systems that seemed to operate in coordination. Ground-based telescopes provided continuous monitoring of the object's emissions and trajectory. Space-based instruments offered views unobstructed by Earth's atmosphere. Radio telescopes around the world worked together as a global array to analyze the object's transmissions with unprecedented precision. The data that emerged from this collaboration painted a picture of an object that defied easy categorization. 3I divided by Atlas showed characteristics of both natural space objects and artificial systems. It was as if someone had taken an asteroid and filled it with advanced technology, then sent it on a million-year journey through interstellar space. The internal structure models. Based on all the observational data, teams of scientists began developing models of 3I divided by Atlas's internal structure. The object's low density, complex electromagnetic emissions, and variable magnetic field suggested an internal architecture unlike anything found in nature. Dr. Amanda Foster from MIT's Department of Aeronautics and Astronautics led a team that created detailed computer models of possible internal structures. Their most successful model depicted 3I divided by Atlas as a largely hollow object with a complex network of internal systems. The model suggested that the object's outer shell was composed of unknown metallic compounds that provided structural integrity and protection from cosmic radiation. Inside this shell, a network of interconnected systems generated the electromagnetic emissions, maintained the internal temperature, and possibly provided propulsion for course corrections. The systems appeared to be powered by some kind of internal energy source that had been operating for potentially millions of years. This was far beyond any technology humans had developed. Our most advanced spacecraft could operate for decades at most, while 3I divided by Atlas had apparently been active throughout its entire journey from another star system. The model also suggested that 3I divided by Atlas contained extensive internal sensing systems that allowed it to monitor its environment and respond to changing conditions. This would explain how the object was able to perform precise course corrections and adjust its emissions in response to solar activity. The approach to Mars. By February 2025, 3i divided by Atlas was close enough to Mars for detailed visual observation. The object appeared as a bright dot moving rapidly against the background stars, visible even to amateur astronomers with modest telescopes. As it approached the red planet, 3i divided by Atlas began exhibiting new behaviors that surprised even the scientists who had been studying it for months. The object's emissions increased in intensity and complexity, as if its internal systems were preparing for something significant. The magnetic field fluctuations became more pronounced, and new types of electromagnetic radiation began appearing in the object's spectrum. Most intriguingly, 3i divided by Atlas began emitting structured radio signals in the direction of Mars, as if it were attempting to communicate with something on or around the planet. These signals were unlike anything the object had produced during its approach through the outer solar system. They contained complex information patterns that seemed designed to convey specific data rather than just broadcasting random transmissions. Dr. Walsh from the SETI Institute worked frantically to decode these new signals, but their structure was far more sophisticated than anything in her experience. The signals seemed to use mathematical concepts and information encoding techniques that were completely alien to human understanding. The Mars orbital insertion. On March 15, 2025, 3i divided by Atlas reached Mars. Telescopes around the world and spacecraft throughout the solar system focused on the red planet as the interstellar visitor made its closest approach. What happened next would be debated by scientists for years to come. As 3i divided by Atlas entered Mars' gravitational field, it began to slow down, but not in the way that orbital mechanics predicted. The object decelerated more rapidly than Mars's gravity alone could account for, as if it were using some form of propulsion to control its approach. Instead of following a hyperbolic trajectory that would carry it past Mars and back into interstellar space, 3i divided by Atlas settled into a stable orbit around the planet. The orbital insertion was executed with a precision that would have been impressive for a human-designed spacecraft, let alone an object that had supposedly been traveling through space without guidance for millions of years. The implications were staggering. 3i divided by Atlas had not only performed course corrections during its journey through the solar system, but it had also executed a complex orbital insertion maneuver around Mars. This level of navigational precision suggested sophisticated guidance systems and propulsion technology far beyond human capabilities. The Mars orbit analysis. Once 3i divided by Atlas had established orbit around Mars, its behavior became even more intriguing. The object settled into a highly elliptical orbit that took it from as close as 8,000 kilometers above the Martian surface to as far as 50,000 kilometers away. This orbital pattern was significant because it provided 3i divided by Atlas with comprehensive coverage of Mars' entire surface and atmosphere. During its close approaches, the object could conduct detailed observations of the planet's surface features. During its distant phases, it could study Mars' interaction with the solar wind and its overall relationship to the rest of the solar system. The orbit also suggested that 3i divided by Atlas was designed for long-term observation rather than just a brief flyby. The object had committed itself to an extended stay in the Martian system, possibly for years or even decades. Dr. Morrison's analysis of the orbital dynamics revealed that 3i divided by Atlas had chosen one of the most stable possible orbits around Mars. The gravitational influences of the Sun and other planets would have minimal effect on the object's trajectory, allowing it to maintain its observational position indefinitely with only minimal course corrections. The surface scanning behavior. Within days of establishing orbit, 3I divided by Atlas began exhibiting what could only be described as systematic scanning behavior. The object's emissions became highly directional, focusing on specific areas of Mars's surface for extended periods before moving on to new regions. The scanning pattern appeared deliberate and thorough. 3I divided by Atlas would spend several hours analyzing one region of Mars, then shift its attention to an adjacent area. Over the course of several weeks, it systematically examined the entire Martian surface. Most intriguingly, the object seemed to show particular interest in certain geological features. It spent extra time studying the massive Olympus Mons volcano, the vast Valles Marineris canyon system, and the polar ice caps. These were some of Mars's most distinctive and scientifically interesting features. 3I divided by Atlas also showed unusual interest in areas where NASA and other space agencies had landed rovers and landers. The object spent considerable time studying the landing sites of Curiosity, Perseverance, and other Mars missions. It was as if the object were specifically examining evidence of human activity on the Red Planet, the communication attempts with Earth. As 3I divided by Atlas continued its detailed study of Mars, scientists on Earth noticed that the object's transmissions were becoming increasingly complex and structured. The emissions seemed to be encoding vast amounts of data about Mars's geology, atmosphere, and surface features. Dr. Walsh and her team at SETI began attempting to establish some form of communication with 3I divided by Atlas. They transmitted mathematical sequences, prime numbers, and basic scientific constants toward the object using powerful radio telescopes. The results were initially disappointing. 3I divided by Atlas continued its systematic scanning of Mars without acknowledging the Earth-based transmissions in any obvious way. However, careful analysis revealed subtle changes in the object's emission patterns that seemed to correlate with the timing of Earth's transmissions. The changes were so subtle that they might have been coincidental, but they occurred with suspicious regularity. Every time Earth transmitted a signal toward 3I divided by Atlas, there was a brief fluctuation in the object's standard emission patterns. After weeks of attempts, Dr. Walsh's team detected what appeared to be a direct response. 3I divided by Atlas transmitted a brief, highly structured signal directly toward Earth. The signal contained mathematical patterns that clearly acknowledged the reception of Earth's earlier transmissions. The data transmission event. On April 22, 2025, 3I divided by Atlas began what could only be described as a massive data transmission event. The object's emissions increased in intensity by several orders of magnitude, and it began broadcasting structured information packets toward multiple destinations throughout the solar system. Some of these transmissions were directed toward Earth, others toward various planets and moons, and still others toward specific coordinates in interstellar space. The transmission event continued for 72 hours, during which 3I divided by Atlas broadcast an enormous amount of information. The Earth-directed portions of the transmission contained what appeared to be detailed scientific data about Mars. The information was encoded using mathematical and physical constants that were universal, allowing human scientists to begin the process of decoding. Initial analysis revealed comprehensive geological surveys of Mars, atmospheric composition data, and detailed maps of surface features. But the data also contained information about subsurface structures and geological processes that human missions to Mars had never detected. Most remarkably, the transmission included data about regions of Mars that were not visible from 3I divided by Atlas's orbital position. The object somehow possessed information about the far side of Mars and its polar regions that it couldn't have collected during its brief time in orbit. The subsurface discoveries. As scientists worked to decode the data transmitted by 3I divided by Atlas, they made discoveries that revolutionized our understanding of Mars. The object had somehow detected vast underground structures that no human mission had ever found. Deep beneath Mars' surface, 3I divided by Atlas had identified a network of caverns and tunnels that extended throughout much of the planet. These subsurface features appeared to be natural formations carved by ancient water flows and geological processes over millions of years. But some of the underground structures showed signs of artificial modification. Certain caverns had been enlarged and connected by tunnels that were too regular and purposeful to be purely natural. Something had modified Mars' subsurface geology, possibly millions of years ago. The implications were staggering. If the data from 3I divided by Atlas was accurate, Mars had once hosted some form of intelligent activity that had left permanent modifications to the planet's geology. These weren't surface structures that had been eroded away by time and weather, but deep underground modifications that had survived for eons. The historical timeline. Further analysis of 3I divided by Atlas's data revealed information about Mars' geological history that painted a picture of a planet that had undergone dramatic changes over time. The object had somehow determined the age of various surface features and geological formations with extraordinary precision. According to the data, Mars had experienced a period of intense geological activity roughly 3.7 billion years ago. During this time, massive construction projects had modified the planet's subsurface structure. The scale of these modifications suggested the work of a civilization with capabilities far beyond current human technology. The timeline also indicated that this ancient activity had ended abruptly around 3.2 billion years ago. Whatever intelligence had been modifying Mars had either left the planet or ceased to exist during this period. Most intriguingly, the data suggested that similar modifications had been made to other bodies in the solar system during the same time period. 3I divided by Atlas had detected evidence of artificial structures on several asteroids and moons that showed the same engineering techniques used on Mars. The Solar System Survey. The scope of 3I divided by Atlas's knowledge became apparent as scientists continued decoding the transmitted data. The object possessed detailed information about every planet, moon, and major asteroid in our solar system. This was information that could only have been collected through direct observation and analysis. The data revealed that 3I divided by Atlas was not the first interstellar visitor to our solar system. Similar objects had been arriving periodically for billions of years, conducting surveys and collecting information before departing for unknown destinations. Each visiting object had left behind detailed records of the solar system's condition at the time of their visit. These records showed how the planets and their environments had changed over geological timescales. They provided a continuous observational history of our solar system spanning billions of years. The most recent previous visit had occurred approximately 65 million years ago, coinciding with the extinction event that killed the dinosaurs on Earth. The data suggested that interstellar visitors had been monitoring our solar system's development, including the evolution of life on Earth. The Earth observations. Among the most striking revelations in 3I divided by Atlas's transmissions were those concerning Earth. The object had been carefully studying our planet during its journey into the solar system, compiling vast amounts of information about human civilization and technology. Its records included wide-ranging surveys of cities, infrastructure, and population centers, along with assessments of our machines and scientific progress from early rocketry to advanced computing. In many respects, the object's knowledge of our capabilities was more comprehensive than our own institutions could easily assemble. Even more surprising was the discovery that 3I divided by Atlas had not begun this study recently. The data stretched back thousands of years, documenting humanity's gradual rise from simple tools to space exploration. The transmissions suggested that Earth's technological progress had long been observed, not by a single visitor, but as part of an ongoing pattern of outside attention. The network of watchers. As scientists pieced together the data, a larger picture began to form. A network of interstellar objects engaged in long-term observation of civilizations across the galaxy. Ours was just one of many star systems under quiet study. The watchers appeared to be operating according to shared principles. They did not intervene directly, but rather observed and recorded. Contact, when it occurred, seemed to depend on specific milestones reached by the civilizations under watch. For some species, the threshold was interstellar travel. For others, it was tied to the development of certain technologies or levels of organization. For humanity, the key moment appeared to be our presence on Mars. Human activity on the red planet had triggered a change in protocol, allowing 3I divided by Atlas to reveal more of its purpose. The Mars connection. Mars's role as a threshold world came into sharper focus as researchers examined further details. The planet was more than a barren neighbor. It had been prepared long ago to serve as a proving ground. Hidden structures beneath its surface were not random remnants, but components of a system designed to evaluate species that reached beyond their home worlds. When humans first set foot on Mars, ancient sensors activated, signaling that another civilization had crossed the threshold. The records showed that many civilizations before us had undergone similar processes, with outcomes that varied widely. Some were invited to join a greater galactic network, while others were left to continue their journey independently. The specifics of these evaluations were not fully clear, but it was evident that humanity had entered a new stage. How we treat Mars, how we manage its environment, and how we respond to the possibility of contact may all influence our place in the wider galaxy. The galactic civilization. One of the most extraordinary revelations in 3I divided by Atlas's data was the existence of a vast galactic civilization extending across thousands of star systems and millions of worlds. This civilization wasn't a single empire, but rather a loosely connected network of species that had reached certain levels of technological and cultural maturity. The Watchers acted as scouts and evaluators for this community, identifying and studying developing societies across the galaxy. When a civilization showed both advancement and readiness, it was invited to participate in the larger galactic network. Membership offered enormous opportunities. Shared knowledge across thousands of species meant access to technologies that could address energy challenges, heal diseases, and even enable faster-than-light travel. Each member contributed its own discoveries, perspectives, and philosophies, adding to the collective wisdom of the galaxy. But joining also came with obligations. Members were expected to assist in the observation and support of new civilizations, to follow ethical principles when interacting with less advanced species, and to contribute to the stability of the larger community. Not all civilizations were ready as soon as they reached interplanetary travel. Many needed additional time to grow before integration was possible. Others chose, or were guided, to continue their paths independently until a later stage. The evaluation criteria. As scientists studied more of 3I divided by Atlas's transmissions, they began to see how civilizations were evaluated. The process was broad, looking at technology, social dynamics, environmental care, and ethical choices. Technology was important, but it was not the sole measure. Some societies had developed advanced machines yet lacked the balance or cooperation needed to interact peacefully with others. Social organization was crucial. Civilizations mired in persistent conflict or severe inequality were often seen as not yet ready for membership. The ability to collaborate across differences was considered a key marker of maturity. Environmental responsibility also mattered. Species that safeguarded their worlds and resources were viewed as better prepared to take part in a community that valued long-term sustainability across many planets. Finally, ethical outlook played a role. How a species treated others, how it used its scientific knowledge, and whether it sought progress without unnecessary harm were all part of the assessment. Humanity's current status. According to the criteria outlined in 3I divided by Atlas's data, humanity's position was mixed. On the one hand, we had achieved remarkable technological progress, extended our reach to Mars, and demonstrated cooperation in many scientific endeavors. Our drive to explore and our curiosity about the universe were noted as strong positives. On the other hand, challenges remained. Conflicts on Earth, environmental pressures, and uneven progress in building equitable societies raised questions about our readiness. The data suggested that humanity was in an early stage of evaluation, a period of close observation rather than immediate decision. Our actions in the coming decades, both on Earth and beyond, would shape the outcome. Mars had triggered the start of this process, but the evaluation would take time. The Watchers, according to the transmissions, would continue to follow humanity's progress, looking for signs that we were moving toward the cooperation and balance required for entry into the galactic community. The technology gifts. One of the most intriguing aspects of 3I divided by Atlas's mission was the possibility of technology transfer. The data suggested that civilizations showing sufficient promise during their evaluation period might receive certain technological gifts to help accelerate their development. These gifts typically took the form of scientific insights or technological principles rather than complete devices or systems. The goal was to help developing civilizations advance while still requiring them to do the work of understanding and implementing new technologies themselves. For humanity, the data transmitted by 3I divided by Atlas itself represented the first such gift. The detailed information about Mars' subsurface structures, the historical data about our solar system, and the insights into galactic civilization were all intended to help accelerate human development. But the data also hinted at more significant gifts that might be available if humanity continued to show promise. Advanced energy technologies that could solve our climate crisis. Medical knowledge that could eliminate many diseases and extend human lifespan. Propulsion systems that could enable true interstellar travel within human lifetimes. The availability of these gifts would depend on humanity's continued progress during the evaluation period. If we could demonstrate that we were worthy of trust and capable of using advanced technologies responsibly, more significant assistance might become available. The warning signs. However, 3I divided by Atlas's data also contain warnings about the consequences of failing the evaluation process. Civilizations that showed dangerous tendencies during their probationary period might face restrictions or even intervention to prevent them from spreading their destructive behaviors to other worlds. The data describes civilizations that had been quarantined to their home solar systems when they proved too aggressive or destructive for galactic membership. Their technological development had been limited, and they had been prevented from achieving interstellar travel capabilities. In extreme cases, civilizations that posed significant threats to galactic stability had faced more direct intervention. The data was vague about the specific methods used, but it was clear that the galactic civilization took its security seriously and was prepared to act against species that threatened the broader community. The extinction event that had killed the dinosaurs on Earth 65 million years ago was mentioned in the data as an example of such intervention. A developing reptilian civilization on Earth had shown extremely aggressive and destructive tendencies. When they began developing space travel capabilities, the decision was made to reset Earth's development by causing a mass extinction event. The implication was clear. Humanity's future was not guaranteed. Our species was being evaluated, and the results of that evaluation would determine whether we would be allowed to continue our expansion into space or whether we would face restrictions or even intervention. The Mars facilities. As 3I divided by Atlas continued its detailed study of Mars, the object began transmitting more specific information about the ancient facilities hidden beneath the planet's surface. These installations represented technology far beyond human capabilities, but they had been designed to interface with developing civilizations that achieved interplanetary travel. The largest facility was located deep beneath Olympus Mons, the massive volcano that dominated Mars's western hemisphere. This installation contained vast databases of information about galactic civilization, advanced manufacturing capabilities, and communication systems that could reach across interstellar distances. The facility had been dormant for millions of years, but the arrival of human missions on Mars had begun to activate some of its systems. Sensors throughout the facility were monitoring human activities on the planet's surface, evaluating our technological capabilities and behavioral patterns. Other facilities were located beneath Mars' polar ice caps and within the depths of Valles Marineris. Each installation served a specific purpose in the evaluation and integration process for developing civilizations. Together, they formed a comprehensive system for assessing species that achieved interplanetary travel. The data suggested that access to these facilities might be granted if humanity continued to show progress during the evaluation period. The knowledge and technology contained within them could accelerate human development by thousands of years, but they would only be made available to species that demonstrated sufficient wisdom and responsibility. The integration timeline. According to 3I divided by Atlas's data, the evaluation process for developing civilizations typically lasted between 50 and 200 years, depending on the species' rate of development and demonstration of key characteristics. For humanity, the process had officially begun with our first permanent settlements on Mars, which meant we were still in the very early stages of evaluation. The timeline suggested that humanity would face increasingly complex challenges and opportunities over the next several decades. Our responses to these tests would determine whether we were invited to join galactic civilization or left to develop independently. The first major milestone would likely occur within the next 20 to 30 years, when humanity's space-based population reached a certain threshold. At that point, we might be granted access to some of the basic facilities on Mars, and given our first real opportunity to demonstrate our readiness for greater responsibility. Subsequent milestones would depend on our progress in addressing Earth's environmental problems, reducing conflicts between human populations, and developing more advanced space travel capabilities. Each achievement would unlock additional opportunities for technology transfer and deeper integration with the galactic community. The final evaluation would likely occur within the next century, when humanity's overall readiness for galactic membership would be assessed. This evaluation would take into account not just our technological achievements, but our social development, environmental stewardship, and ethical behavior over the entire evaluation period. The other visitors. 3I divided by Atlas's data also revealed that it was not the only interstellar visitor currently in our solar system. Several other objects from the Watcher network were positioned throughout the solar system, conducting their own specialized observations and evaluations. These objects were far more subtle than 3i divided by Atlas, designed to remain undetected while gathering specific types of data. Some were observing human behavior on Earth, monitoring our cities, governments, and social institutions. Others were studying our space-based activities, evaluating our technological development and expansion into the solar system. The network of watchers maintained constant communication with each other, sharing data and coordinating their observations. This allowed them to build a comprehensive picture of human civilization from multiple perspectives and evaluate our progress against the standards required for galactic membership. The data suggested that humanity had been under more intensive observation than we had ever realized. Every major human achievement, from the first moon landing to the establishment of Mars colonies, had been carefully documented and analyzed by multiple interstellar visitors. This level of scrutiny was both reassuring and intimidating. On one hand, it suggested that humanity was considered significant enough to warrant such detailed attention. On the other hand, it meant that our species was being judged by standards we didn't fully understand, with consequences we could barely imagine. The communication protocols. As the scientific community worked to understand the implications of 3i divided by Atlas's revelations, attention turned to the question of how humanity should respond. The object had clearly demonstrated its willingness to share information, but it had also made clear that it was evaluating our species based on our responses. The data transmitted by 3i divided by Atlas included specific protocols for communication with the Watcher network. These protocols outlined acceptable methods for sending messages, appropriate content for interstellar communication, and procedures for requesting additional information or assistance. The protocols were designed to test developing civilizations' ability to communicate respectfully and responsibly with more advanced species. They required careful attention to cultural sensitivity, scientific accuracy, and ethical considerations. Most importantly, the protocols made clear that any communication with the Watchers would be considered part of humanity's ongoing evaluation. Our messages would be analyzed not just for their content, but for what they revealed about human character, intelligence, and readiness for galactic membership. This placed enormous pressure on the international scientific community to craft responses that would represent humanity in the best possible light while remaining truthful and authentic. The stakes couldn't be higher. Humanity's future in the galaxy might depend on how well we handled our first formal communication with an extraterrestrial intelligence. The global response coordination. The revelation that humanity was being evaluated by a galactic civilization prompted unprecedented cooperation between world governments and scientific institutions. The United Nations quickly established a new office dedicated to coordinating humanity's response to the 3i divided by Atlas contact. This office, formerly known as the UN Office for Extraterrestrial Contact, brought together the world's leading scientists, diplomats, and ethicists to develop a unified human response to the Watcher network. For the first time in human history, the entire species was working together toward a common goal. The office's primary responsibility was crafting humanity's formal response to 3i divided by Atlas's data transmission. This response would serve as our species' introduction to the galactic community and would likely influence the entire course of our evaluation process. The response team included representatives from every major nation on Earth, as well as leading figures from scientific, religious, and cultural institutions. The diversity of perspectives was considered essential for creating a response that truly represented all of humanity rather than just the views of a few powerful countries or organizations. The process of crafting this response revealed both humanity's greatest strengths and its most significant weaknesses. Our ability to come together in the face of a common challenge was impressive, but our continuing disagreements and conflicts made it difficult to present a unified voice to the galactic community. On June 21st, 2025, exactly 3 months after 3I divided by Atlas had established orbit around Mars, humanity transmitted its formal response to the interstellar visitor. The message, broadcast simultaneously from radio telescopes around the world, represented the most important communication in human history. The response began with a simple acknowledgement of the data received from 3I divided by Atlas and gratitude for the information shared. It outlined humanity's current understanding of our place in the galaxy and our recognition that we were being evaluated for potential membership in a larger galactic community. The message described humanity's achievements and aspirations while acknowledging our flaws and ongoing challenges. It demonstrated our commitment to continued development and our desire to contribute positively to the galactic civilization if we were deemed worthy of membership. Most importantly, the response included humanity's formal request for guidance on how we could better meet the standards required for galactic membership. We asked for specific feedback on our areas of weakness and suggestions for how we could improve our evaluation status. The transmission of this message marked the end of humanity's isolation in the universe. For the first time in our species' history, we had formally acknowledged our awareness of extraterrestrial intelligence and requested to join a community of galactic civilizations. 3I divided by Atlas's response came within hours of receiving humanity's message. The interstellar visitor began transmitting a new series of data packets that contained detailed feedback on humanity's current status and specific recommendations for areas of improvement. The feedback was both encouraging and sobering. Humanity showed significant promise in many areas, particularly our scientific curiosity, technological innovation, and recent improvements in international cooperation. However, we also had major deficiencies that needed to be addressed before we could be considered for galactic membership. The most critical areas for improvement were environmental stewardship, social equality, and conflict resolution. The galactic civilization had seen too many promising species destroy themselves through environmental collapse or internal conflicts to risk admitting civilizations that hadn't demonstrated mastery of these challenges. But perhaps most remarkably, 3I divided by Atlas's response included an offer of direct assistance. If humanity was willing to accept guidance and demonstrate genuine commitment to addressing our deficiencies, the Watcher Network was prepared to provide technological and scientific assistance to accelerate our development. This assistance would come in the form of gradual technology transfers, scientific insights, and access to some of the facilities hidden beneath Mars's surface. The help would be carefully calibrated to challenge humanity to grow and develop rather than simply providing us with advanced capabilities we weren't ready to handle responsibly. The offer came with strict conditions. Humanity would need to establish a unified global government capable of making decisions for the entire species. We would need to implement comprehensive environmental protection measures to begin reversing the damage we had done to Earth. And we would need to demonstrate that we could resolve conflicts peacefully rather than through violence. These conditions were non-negotiable. The galactic civilization had learned from experience that species unable to meet these basic requirements were not ready for the responsibilities that came with membership in an interstellar community. As I record this final update to our ongoing coverage of the 3I divided by Atlas situation, humanity stands at the most important crossroads in our species' history. We have discovered that we are not alone in the universe, that we are being evaluated by a vast galactic civilization, and that our actions over the next few decades will determine whether we join that civilization or remain isolated in our small corner of the galaxy. The revelations brought by 3I divided by Atlas have fundamentally changed our understanding of our place in the universe. We now know that Earth has been under observation for millennia, that our technological development has been carefully monitored, and that our species is currently undergoing the most important test we have ever faced. The data provided by our interstellar visitor has given us unprecedented insights into Mars' hidden history, the existence of ancient facilities beneath its surface, and the presence of a galaxy-spanning network of civilizations that has been watching our development with great interest. We have learned that our arrival on Mars triggered an evaluation process that will determine humanity's future role in the galaxy. We have been offered assistance and guidance, but only if we can demonstrate that we are capable of the wisdom and responsibility required for membership in a galactic community. The challenges ahead are enormous. We must learn to work together as a single species rather than competing nations. We must heal the environmental damage we have done to our home planet. We must find ways to resolve our conflicts without violence and create a more equitable society for all humans. But the potential rewards are beyond imagination. Access to technologies that could solve our energy crisis, cure our diseases, and enable us to travel to the stars. Knowledge gathered from thousands of different civilizations across the galaxy. The opportunity to contribute to a community that spans vast distances and encompasses forms of life we can barely imagine. 3I divided by Atlas remains in orbit around Mars, continuing its detailed evaluation of human activities both on the red planet and on Earth. The object serves as our constant reminder that we are being watched, judged, and offered an opportunity that may never come again. The decisions we make in the coming years will echo through human history for generations to come. We have been given a chance to join something greater than ourselves, to become part of a galactic civilization that has existed for millions of years and encompasses countless worlds and species. But that opportunity comes with a price. We must prove that we are worthy of the trust being placed in us. We must demonstrate that humanity can be responsible stewards of advanced technology and reliable partners in a community of galactic civilizations. The choice is ours. We can continue on our current path, remaining isolated and struggling with the same problems that have plagued our species for centuries. Or we can embrace the challenge of becoming something greater, something worthy of our place among the stars. 3I divided by Atlas has shown us what is possible. The ancient facilities beneath Mars stand ready to share their knowledge with us. The galactic civilization waits to see if humanity is ready to join them. The next chapter of human history is about to begin, and it will be written among the stars. Subscribe for updates on humanity's most important journey.